Assalamualaikum and greetings, guys. For this chapter, we'll be talking about control charts and their interpretations. The construction of charts will be covered in class. Now, control charts can be constructed and evaluated continuously to guide in the production of acceptable quality products. From your company's viewpoint, this is the most visible and the most useful function of the quality control manager. So, what is a control chart? Control charts are a continuous picture of the process, and when properly constructed, the chart will provide the means of continuously producing product of uniform quality. When a single point falls outside of the control limits, something is probably wrong. There are some general principles relating to data points which appear outside of the control limits. Data on a variable chart may first exceed the control limits in one of three ways. 1. If the average is out of limits but the range is not, chances are that there is a serious problem with the process. When this occurs, chances are all of the observations in the subgroups are out of control or nearly so. If the range is out of limits but the average is not, the process may be on the verge of developing an oscillation. The process is expected to soon drive the average out of limits as well. It is likely that the individual items are already close to or outside of the specification limit. And finally, the third way, if both the average and the range are out of limits, something drastic has occurred, and it can be expected to become worse unless immediate action is taken. Let's have a look at some of the chart patterns. Chart pattern number 1 is normal. It is in control. The pattern is random and within the control limits. Therefore, no action is needed or desirable. You are good to continue with the process. The second chart pattern is called random cycles. When found in the X bar chart, the causes may be due to rotation of operators or machines, merging processes such as feeding rework material into the line or alternating raw materials and supplies, changes in environmental conditions such as temperature, humidity, or sometimes you have fatigue workers. If this is found on the range chart, the causes may be due to inadequate maintenance of equipment, resulting in wear and intermittent operation. Chart pattern number 3, trend. It can go up or it can go down. The chart for averages for a may trend in one direction, as shown here, as one raw material is used up and another is introduced. Gradual deterioration of equipment, continuous change in the environment, or change in the production rate will also produce a trend. A trending range chart may be the results of gradual improvement or deteriorations of worker skill or production rate change or change in the number of components reaching the process. So when you see this particular pattern, you should be aware that something is going on, even though the values are still within the control limits. Well, there is such thing as abnormal uniformity. This is chart pattern number 4. So sometimes you have reduced scattering of observations, probably because you have a superior skilled employees around, or when the process has been changed, or when defect-free raw materials are introduced, or when unusually very favorable environmental conditions exist, or when the wrong control limits are used. So non-random samples selected by improperly trained employee can result in the uniform result as well. Or sometimes you happen to use a malfunction instrument, or some instrument that is not properly calibrated. Maybe during chemical testing you do not use proper or maybe outdated reagent, will also result in abnormal uniform quality. Compared to the X-bar chart, range chart are more sensitive to conditions leading to abnormal uniformity. Chart pattern number 5 is called recurring cycles. Chart which shows cycles may be related to activities which occur at repeated times, such as days, shifts, hours, or break periods. When changes in the process or the environment occur regularly, the changes may be in workers, supervisors, inspectors, schedule maintenance, ambient temperature or humidity, lighting or production equipment rotation. Non-uniform cycle may be traced to occasional temporary equipment stoppages for adjustment or repair. So this may produce new quality levels when restarting. Occasionally, a control chart plot lies far outside the limits with no apparent cause. This is called wild outliers, chart pattern number 6. Generally, this is due to quality testing error. The list of errors include calculation mistakes, plotting mistakes, sample size mistakes, sampling procedures mistakes, even testing mistakes, or worse, sample contaminations. Problems associated with the production lines are actually very rare and generally non-repetitive. There could be several more explanations or interpretation of chart patterns. So whatever I explained just now, it was not complete. So sometimes you have to do some kind of detective work in order for you to find the explanation when you see out of limits data in the control charts. But most of the answers are found on the production floor, or better still, at the raw material supplier plant. And as the relationship between quality control personnel and operating personnel grows closer, the answers and solutions to production quality problems are found more readily.